The Litle case study, providing actionable information from instrumented apps. My name is Gia Mangino, and I'll be your moderator for today's event. Our presenters today are Dan Abramovich and Rodney Morrison. Dan Abramovich is a software engineer with almost 15 years of experience working with highly available mission-critical systems. He's currently a technical lead in the production engineering group at Litle Company, a leader in payment management and processing, specializing for businesses that sell goods and services directly to consumers. Dan's group is responsible for the scalability, availability, and monitoring of the Litle payments platform. As Vice President of Products, Rodney Morrison is responsible for product management, tracking market industry trends, as well as competitive analysis for SL Corporation. Rodney has had several roles since joining SL in 1988 as part of the development team, including technical sales support, managing software development, developing the VAR network in Europe, and managing sales and marketing efforts in Europe and Japan. Prior to SL, Rodney was a software development engineer and manager focusing on real-time embedded systems at Texas Instruments, Lighton Industries, and E-Systems. Rodney holds a bachelor's degree in electrical engineering from the University of Kansas. After today's presentations, there will be time left at the end to address questions from the audience. If you'd like to participate in the Q&A session, simply enter your questions into the chat panel at any time during the event and click Submit. With that, I'll pass it over to you, Dan. Thank you.
Thank you, Gina. As Gina said, my name is Dan Abramovich. I'm a software engineer at Litle. My group of most interest today is responsible for ensuring monitoring, good and effective monitoring of our platform. And what Litle Co does, we provide payment management and processing services for what we call card not present. So for both traditional credit card payments and alternative payments, such as PayPal and Bill Me Later, anywhere where the customer is not directly face-to-face with their consumer. And what we're monitoring really is our payments platform. And this is really the core to Litle's business. We provide both real-time and batch processing for payments transactions. And that means that we're, in terms of real-time, giving responses directly back to our merchants' customers, so end users. A decline or an authorization, processing that credit card payment in real time. We have many thousands of merchants and process millions of transactions per day. And we have very high uptime requirements. Basically, the system is always available. There is no scheduled downtime for maintenance. So monitoring is very, very key to our business. And a couple of years ago, we really decided that it was important to strengthen this capability. And we realized that we very much needed more visibility into our own applications. We had data in some places, but it wasn't necessarily easily accessible. We had data from our Oracle Coherence cache cluster, from our own applications, from our application database, from other databases that had, for example, our database group has created to provide health of the application database, but it wasn't really very well accessible. And we were, pretty much tired of manual queries and log mining. It's time-consuming, and it requires more expertise than really should be required to get at, good information about your own system. In particular, with respect to JMX information, which is sort of the classic way that people instrument, Java applications is with MBeans, with JMX. What we found is that that's all well and good, but it really doesn't do you any good unless you can aggregate that information. It's just not practical to go to individual, JMX consoles like JConsole and get at sort of per process information. It doesn't really tell you anything unless it's rolled up and looked at as a whole. If any people out there use Oracle Coherence, you know that they have lots and lots of MBean data, but to look at the information for one cache process doesn't really tell you anything. You really need to bubble it up to a higher level. So why did we choose RTView in particular to help solve these problems? one thing that struck us about the tool was that it has very, very rich and computational features, meaning that it allows us to do just that kind of aggregation that I was just talking about. So the other advantage to this, the computational features, is that it really allows us to push as much of the work into the monitoring tool and out of the application, which we really want processing payment transactions, not having to deal with aggregation and computations for monitoring. That gives you a couple things. It makes the application lighter weight; it doesn't have to do extra work. And it's also more flexible in that as long as the basic data is getting into the tool, to make a change doesn't require a code change to your core application. You can do the work in the tool and leave the application alone, which is usually a very good thing. The other sort of key aspect here was as a data integrator, meaning that not only are we looking at data from our application, but from other systems as well. This is the sort of single pane of glass that everyone talks about these days. I mentioned our own availability requirements for our application. We expected the same of our monitoring tool. And RTView does have a high availability deployment option, which we do use, which if we need to take the server down for whatever reason, we don't lose data. We don't lose our statistics, which is very important to us. Specifically related to JMX, which was a key requirement, RTView is very good at this. It doesn't require special configuration or manual configuration to talk to a particular MBean. It knows how to do MBean queries and look across all of the MBean servers that it knows about and aggregate that data very well. In particular, with the flavor of RTView that we are deploying is called OCM, which is specifically designed to monitor Oracle Coherence, and it actually taps into Coherence's management framework, joins the cluster, and actually can get at the JMX data by virtue of being a member of the cluster. And I'll talk a little bit more about how we were able to leverage that for us in particular later. So how are we actually using RTView here? I guess we can talk about sort of two different classes of usage. Real-time and as the sort of integrator. For us, the critical real-time data is our transaction rates and our response times. And this specifically, especially in the sense of real-time, refers to an online transaction. So someone is submitting a payment and needs that response right away. And the really nice thing that we're able to do with RTView is that we can slice and dice this data in many different ways. By card type, Visa, MasterCard, Discover. By transaction type, a deposit or a refund. By our merchants and by the particular server that the transaction was processed on. It allows us to see the data in lots of different ways. The other sort of category of usage is as a single monitoring interface across all the different systems and data sources that we have and are interested in. This means application metrics, and we're pulling in data via JMX, via JMS, and which is our real-time data that I was just talking about. We publish JMS messages with key metrics for our transactions, and RTView subscribes to those. And via SQL for our own application database in some cases. I mentioned the cache stats before. I think I also touched on the fact that our database group has a health metrics database, which we can query with RTView. And another interesting thing that we're able to do with the tool, we contract with a third-party service to monitor our application from outside of our own network. And it sends some, simple tests to see how we are doing from an external perspective. And we're able to use RTVU's custom data adapter to pull that data in and visualize that data the same way we view our own application data. So that's sort of a summary of the different kind of things that we're doing with the tool. So this works for us, and in some sense not always in the expected ways. Yes, we have all this great data, and it gives us, quick access to the information. Some of the data we were able to probably get to before, but it was a tedious, time-consuming process. And it wasn't always consistent in how people would get at that data. So you may have, multiple answers to the same question. It allows better cross-pollination of groups. So we have data in the tool that would normally be accessed by our DBAs, but they can now get at our application data and see how that all relates, and vice versa. So the engineers and the support people have also much better visibility into what the database is doing. And that's been very powerful for us. And that's what I kind of mean by liberating the data from the niche system. People have really found that they have access to data that's been available to them for a long time, but now they can really get at it and use it, see it side by side, other data such as, application statistics, and really make good use of it. And the funny thing about having all this data in one place is that it really helps us learn about our own application, which, may sound a little bit silly, but what we came to see is that we could visualize via the views, via the graphs and charts, what normal meant. You begin to see patterns and of course abnormalities. It's very interesting when you see day on day of what, how things usually look. When something is different, it very much stands out. And it triggers, investigation, sometimes within RTView, sometimes using other tools, to find out what's going on. And actually interesting, when we first deployed the tool, one of the things that we noticed, looking at probably one of our first views, which was our transaction rates broken down by the server that was processing those transactions. We found that early every morning we would see a big spike in our transaction rate. And some people were actually kind of questioning, is that really happening? We really weren't aware of that. And what we found out is that one of our merchants was effectively using our real-time interface as a batch interface. They were saving up all of their transactions for the day, and early in the morning we're sending them through one by one. It's not necessarily a problem, but it's just sort of an interesting example how we learned how people were using our own systems. So I want to jump in and talk a little bit about and give everyone a flavor of what the deployment here at Litle looks like. Everything in the blue box is related to the operations of RTView. The database for the historian is provided by us, but is to service RTView. The data server is the key component within RTView, which is, as you might expect, collecting and serving all the data. In our particular deployment, because we use the Oracle Coherence monitor product, that data server actually joins the Coherence cluster and can actually get data from both the cache processes and our applications via JMX data via the Coherence cluster, the Coherence management framework. And that has simplified some things for our particular deployment. We're also pulling in data from our own application database, from the sort of database health database, and from that external monitoring service that I was talking about. Our production network is deployed behind a firewall, so for us, the way we access this data is through the browser interface and just punch the hole through the firewall just for the web traffic. I guess I should mention, we operated, and I'll show you a picture of this later. We operated multiple data centers. So there's sort of a complete clone of this at 2 locations. And within each data center, the high availability deployment, which is doing, kind of the same thing. So I've mentioned the coherence a couple times. I'll go quickly through this since I'm sure it doesn't apply to everyone. But one thing we were able to do because of the RTView integration with Oracle Coherence is use that integration to collect not only data about the cluster, but our own application metrics. And we were able to create our own endings, put that data into Coherence, and then get at that through RTView. It simplified a number of things for us in that each of the different application processes didn't need to expose a remote JMX interface. That all flows through the cluster, and then RTView acts as a single point of aggregation. And we didn't have to tell RTView about every single process. So all the different ports and overhead that entails. This was very, very simple for us. And there's also some efficiency gains by using the proprietary communication of the cache cluster. So now I just want to sort of finish and give you a couple of visuals of what our deployment really looks like. This is the browser interface, and you can see on the left side, pretty standard navigation tree. We have it broken out by sort of functional area for us, our OLCP, our online views, batch session, database views, and then the Coherence Monitor are the built-in views that come by using the Coherence Monitor version of RTView, which are all available to us. In this particular view, this is showing the total response times for our online transactions alongside the endpoint response times, which in our case means the card network. So how much time is being spent in our system versus, Visa, MasterCard, American Express, etc. What the big spike on the left was is that one of our endpoints, one of the card networks, was actually having a problem. So we see a big spike in yellow, and in this case, since the problem was on their side, you can see the proportion. We immediately were able to tell that, yes, things were slowing down, but the problem was on the card network, and someone could pick up the phone and try and find out what was going on. This view shows the integration with the external monitoring service that we have, and we're pulling in data via their API, which is an XML, a REST API, bringing that, normalizing that data into RTView in a custom adapter, and then able to show it alongside our data, just like any other piece of data going into this hole. This is sort of an interesting graph to us. Every once in a while, I mentioned we operate at multiple data centers, and every once in a while we flip back and forth to exercise the services of those data centers. And this is showing in RTView what one of those flips looks like. So we're processing happily across a number of different servers. Over on the left is site A. When we actually transfer to our alternate site, we use a standalone server that's picking up all the traffic for a short amount of time, and that's in red because he's standalone. And then when we go back to normal operation, it sort of blooms back into the multicolor as each of the different servers takes on the traffic. So this is sort of both RTViews, the views from both RTViews of the different sites shown side by side, and it gives at least for us, an excellent picture of what happens during this period. And the last one I'm going to show here is two views. The one on the bottom right is a view from the collection of views that are monitoring that database, that health metrics database that we have, that our database administrators have put together. And it's showing, what the database is doing, what time is going to read, to write. And you see where the little dot is that we started to bloom red here with a little bit of block time. It's not a good thing. So we built the view that we could do a drill down in RTView. So just simply by clicking on that point, we're able to pop up another view which goes down, which does some other database queries and actually pulls back via this same health metrics database what was actually going on in the system at this time. And this has been extremely valuable in our organization and has really accomplished what I was talking about of letting of allowing data from disparate sources to be available to the entire organization. It immediately gave access to some very specialized data that only the DBAs were seeing to really all of our engineers and our support organization, and that's really been very valuable. And I think is a really good indicator of the kind of things that you can do with the tool. So both the real-time side and this is a more static query going to the database, but it all pulls it together very nicely. So I think that really gives a good picture of how we're using the tool. We're using it both for real time and as an integrator. We've done maybe some unique things by integrating with Coherence in a certain way, but all of that is possible. So with that, I want to turn it over to Rodney to handle the rest of the presentation.
Great. Thanks so much, Dan, for taking the time to put together all this information, describing your solution and how it's impacted your monitoring of your critical services. We really, really appreciate your efforts. Thanks a lot. I'm going to be shifting to another presentation here. Just give me a second. And I'm going to be talking about availability and performance of applications. What's happening now is really in today's environment, we're getting increasingly more and more complex application architectures, and it's really exponentially growing. And understanding how we're going to answer the question about whether an application or service is available and performing well is becoming more and more difficult. So organizations are being driven, and sometimes by the business, to evaluate where they can make changes to provide better answers. So first today I'm going to talk about a maturity model that we've sort of put together, which is useful to look at to determine where your organization fits in that model and where you might see gaps that, if filled, could deliver lots of value. And then I'm going to talk specifically about how RTView fits in that model and which gaps do we fill. And finally, I'm going to go in a little bit of detail about how we do it. So to talk about the model, let's talk about sort of the first level of maturity. And oftentimes, these types of organizations that are at this level are putting together things like maybe infrastructure monitoring. And by that, I mean they're looking at all the hosts or their virtual machines of their system and trying to determine what CPU and memory usage is being consumed. And they may use open source solutions like Nagios or Ganglia or monitoring provided through VM platforms. Then the next category I kind of call runbook procedures, and this is like every day someone comes to work and their job is to ping the server and make sure it's alive, or they putty into a server and they look at a log file and see if there's errors there. A little bit more advanced than this is sort of where Litle went in the beginning, which is ad hoc application monitoring. They had instrumented their apps, and initially they're trying to figure out, well, what do I do with that instrumentation data? And sometimes people put it in a database. Litle thought about I should put it in a cluster. But then how do I act on that data? How do I actually use it is a complication. And the same thing happens when people try to do their ad hoc component monitoring in sort of the same fashion. Some people use JConsole. They'll bring it up to look and see what Java heap usage is, CPU usage, or garbage collection is on a particular process, but that becomes very limited because there's no aggregation across those multiple processes. And more important, there's no history, so oftentimes this can be even less useful than looking at a log file. As people get up, they've got more complicated applications or processes, they're getting more pressure and providing performance and availability information. They often start going into a phase which I've labeled silo monitoring and triage, and I'll explain why I called it that. It means they've purchased probably or built themselves different monitoring pieces that are really focused at looking at the different components of the application architecture. So they may have an infrastructure monitor looking at CPU usage and memory usage of hosts. They want to look at network or databases. Middleware might involve application servers or message brokers or data grids or even specific application performance tools that might be doing things like bytecode instrumentation or end-user experience. And so what this happens when organizations get into this stage is that they evolve technical silos of expertise. So they have each group in sort of the IT and support departments that are specialized with the tools and information that are gathered around these different components of the architecture. And application support teams that maybe understand how these things work together to actually support a service really are very limited as to what information they get. They may get emails or SMS messages that are performed by events from these monitoring systems, but then they just get a barrage of messages that have little context and sometimes very little value or no value in troubleshooting. So what happens is that when outages really happen, then sort of a war room scenario starts, and a meeting is gathered, and all the technical people, support teams that know these different components get together, and what it often results in is that each team describes how it's not their fault. So that becomes a nerve-wracking experience and also a very time-consuming experience, and that's when people start thinking they need to move to really level 3, which is called service and business aligned. And, you know, when you get this sort of information, you're talking about how do I provide value of gathering all of this performance data and how it impacts the service or business as it might apply to IT operations or technology teams. They're trying to keep the base components running, provisioned and running. It might be the dev and QA teams that want to understand how these components interact to understand the impact of change or load testing environments. And more importantly, maybe even application support teams. They're the ones that understand the architecture of the service, and they want to be able to have aggregated views and summaries and drilled out information, and even events that are more specific to them, not kind of events that the infrastructure teams might get, the events that really they think might impact the service, and then being able to drill down and diagnose problems quickly. Sometimes also these views or this view of this type of information is used by the business. So they're determining how the business is being supported by IT, determining areas that might need investment, capacity planning, or determining how service levels might be impacting the business or revenue itself. So where does RTView for APM fit? Well, actually, level 2 there, we do have a lot of monitoring solutions that gather package solutions that gather specific metrics specifically around databases, middleware, application servers, message brokers, data grids, application performance. And so we do provide special packaged ways for gathering that information, providing alerts against them and that sort of thing. But I'm not going to focus on that today. I'm mostly going to focus on level 3. The nice thing about RTView for APM is that then you can look at this service model, figure out which of these little components are important to the performance and availability of your application and which ones are going to have the biggest impact, and decide whether you're going to use those features of RTView, or maybe you even already have monitoring tools that do these things and you just want to integrate that into the whole solution. So I want to talk specifically about the different areas that are involved in the service and business aligned level. And first of all, single pane of glass. And what this typically means to everyone is that I have a way to summarize the information that's provided by these different performance metrics and drill down to details of that when I see a problem. I also want to have role-based views so I can actually address the way I want to look at that data depending on what's my job. Also involved here is really history. How do I get all that information? How do I get access to it quickly, and how do I persist it? So I can do correlation of information across periods of time. When something goes down, you want to look at it at a certain time period and understand how all the components are performing at that time slot. So it also then well, at least our RTD solution provides the ability to see that information either in a web browser environment, desktop environments, or also mobile devices. Another interesting part of this type of functionality is reports. Do I want to have ad hoc reports where I see something, I want to make a report and email it to someone, or I want to have more automated reports generated at a certain periodic basis? Also important is event correlation, and this is where you're aggregating all of the alerts. A lot of these different monitoring type of systems that you might have in level 2 are all generating different alerts. And sometimes they're not that smart. They might be generating alert every, minute or so on the same thing. And so, it's like, I know that one's in an alert state, don't need to tell me again, and I don't need to manage that specific alert, so the deduplication does that. Alert enrichment is about being able to take the kind of alert information you're getting from the different components and enrich it. And what that means is that I can understand the context of that alert, or maybe how I want a certain group or a certain role to be able to act on that alert. Correlation involves being able to understand how those events correlate to either a specific component or a service, or being able to correlate various different events and understand that a combination of those events mean something different that we need to analyze. Also important is defining event actions. What automated things do I want to have happen? Do I want emails sent out? Do I want to integrate with other tools that are consuming alert events? And an interesting thing, too, is alert event history, because sometimes you don't really want to act on every event. You want to see, am I getting an alert event across a period of time? Oh, this one's in stress, or it's in stress during this certain time of day. And alert persistence, which is, sort of having a way to store that information so that either, basically I could even analyze it with other tools if I wanted to. Another big part of service and business level is being able to understand, do I want to have a human interaction with these events? Do I want to have people looking at events and actually, owning them, saying, I, for example, have taken this alert, I'm going to do something about it. Do I acknowledge that alert? Do I want to suppress it, meaning that alert really doesn't matter. It's still there. Nobody's going to work on it, but I don't want it to show impact as far as whether it's going to. I want to actually designate that it doesn't have impact on a particular service. I can add comments to it to say I've looked at it and this is the resolution of it. That can even be viewed later for understanding how you've solved a particular problem. Also tweaking thresholds. Sometimes, as you're fine-tuning the system, you'll realize that this particular component, this particular piece of data is really, the thresholds are wrong and they're giving us false alerts. Enable and disabling the alerts. So, for example, if you're in maintenance mode, you don't want to have a barrage of alerts happening, you know it's down. And an interesting piece of this is also auditing. And this is being able to track and audit what these human interactions have been happening. And that's really to be able to look and see, refine your workflow and the procedures to understand when there's human error, ways that you can do it better. And finally, business impact. And this is a really interesting part of RTView, which allows you to have what we call a dynamic service model. And it's a hierarchical model that allows you to describe, from top down, a business unit. This business unit has these services. These services depend on these particular components of the application architecture. And consume those alerts from all your various different sources of performance data and do propagation so that I can see top-level views of, is the service in stress, and then drill down and see why. Also part of this piece is service criticality. So you can, it's not just how many alerts or what severity of all the alerts are on a service, but how important is that service to my organization. So you can give some higher or lower priority so that as you look at top-level views, you can know this service may only have 2 alerts, severe alerts, but it's a critical one, and I need to drill down on it first. So let's look a little bit about how we do it. This is the simplest RTV for APM deployment architecture and is one that Dan had shown previously. These gray boxes are all Java processes, RTU is a Java application. And in its simplest form, they could all be run on one box, on one host system. They can also be separated out when you want to scale, and I'll talk about a little bit more about that later. To drill down into what the client means, we have a variety of different options for the client. One is a desktop. You can run this interface through and on your desktop with a Java application we call the RTU viewer, and it is configured by XML files which are generated by our RTU builder. I'll just show a few shots there of that. It's a really unique part of it, so that allows you to construct really configurable views of how you want the interface to look like. You can start with what we have and modify them, or even create things all on your own. The other option is a browser client, and that's available to provide the same sort of interface through a browser. And the other unique, I think, well, very unique part of RTU is that those same configuration files that drive the user interface look and feel can be used without modification to have both a desktop or Java browser client view of the information. Let's move down to the bottom of the architecture, which is talking about the data server. And what the data server's role is, it can either in an agentless or an agent mode get the performance data. Oftentimes that data is very raw, and it needs to be transformed into a form that's usable, joined, aggregated, that sort of thing. And so within RTU, there's a lot of different data functions that are just out of the box. You can say, get this data, transform it, and then it's put into caches. Caches are in-memory caches where we can store the information and optionally define how it's going to be archived off into a database via the historian. We provide these caches because they provide very quick access, so you can get really granular real-time information to your client. Also, as part of the data server is often the rule definition. So here you're defining what type of rules need to be activated. It's looking at your cache data as it's coming in live, and it's generating alert events when it determines that there's an alert condition. Those alert events are then propagated up to our central alert data server, and that's where all of the information about how to do alert propagation and work against the dependency model, that's where all of that calculations are done. And if the client then requests things, they see a summary screen, here's an issue, and I'm going to drill down to see what it is, then it's then requested from the data server itself. And this architecture really helps us scale because in some systems, they try to push all the data into some central repository, and that's where the client connects to. And oftentimes that means you have to be really limited as far as the rate of data you can collect and the amount of data you can collect, because it's the slowness of some sort of central monolithic data store. So one other thing I did want to mention here is that this collection that I'm showing here inside this data server, the data transforms, the caches, the alert rules, those are all things that we've configured with our RTU builder. So this isn't a programming exercise. You go in the builder and you can configure this, but in addition to that, we've done this for you for a variety of different technologies, and we call them solution packages. So that means we've constructed all the XML config files that might, for example, be gathering data from your application server. It knows which data to get, how to get it. It does the transformations on the data. It stores them in caches, and we even write what we think are the kinds of things you would want to alert against, and we create the rules for you. So how does it scale? Well, it depends on, it scales from very small to very large. You know, one of the things that RTU is used for is very, very large organizations that are really stayed in level 2 for many, many years. And so they have so much data and no one can act on it. And they also want to have global, follow the sun type of monitoring. So one option is to partition it in each area, but sometimes they really want a global view. They want to be able to look at their service and application performance and availability as as the sun's moving around the globe. And how they do that is that at each data center they have different RTView data servers there, which are gathering the metrics, putting in the caches, generating alert events against all their application middleware and infrastructure at each data center. Those alert events are then populated to a central alert config server, and then you have a central display server that via browser views can be accessed worldwide. This integration allows you then to have the ability to have the data stored really gathered and stored in caches at the local data centers and not require it all to be populated to one centralized data center. So just a brief, I won't go over this in detail, but so the standard solution packages we have out there that you can just deploy and start getting data from are mentioned here. Like I said before, that means we've defined data collection, we've defined how they're cached, history, alert rules against that. You can just plug it into the system and you start getting the information. However, the thing is if you have one not on the list or you have a specialized one, then a custom solution package is not a programming effort. You can use our standard data adapters to get the data, performance data from a variety of different sources. It might be in a database, it might be achieved via JMX, or maybe it comes in from JMS messages, or a variety of different standard data adapters we have to get access to data. And then via the builder, you can runtime, look at that, connect to those sources, see the data right in the builder, configure your alert rules, and define your caches. How am I going to store this data? And how am I going to transform this data and store it? So lastly, I'm going to look at the builder just really briefly. It's really a very unique part of RTV. You're not going to really see this in any sort of product that's performing this kind of, or is trying to put together this kind of solution. And the difference is that in most cases, if you want to make ad hoc type of customized displays of data in these types of real-time systems, you're going to have often very limited ways to do that. They often give you some, if they have it at all, they give you something like, here's the chart type I want, and here's the metric I want, and it starts plotting it. But RTV Builder really has the ability to take the current default existing interfaces that we give you and modify it or create your own. And it's a drag and drop environment with multiple different both sort of presentation options as well as interaction options. So, you can even have text entry and more dialogue-based interfaces there. Drag and drop and setting properties, and you can see everything you're doing live while you're in the builder. It's not a creation and then you have to go to deploy to see how it works. You see everything live. In addition to that is construction of the actual data access. So also from the builder, you can go out through our different data adapters, construct your queries, and define your caches, define your rules right from within the builder, and being able to then define your data server collection, transformation, storage, and alert rules right through the builder. So that's how you can create your sort of custom-built access to data. So really, no matter the level of your maturity your organization is in, RTV for APM has many of the building blocks that will fill the gaps that you can identify as providing the maximum value for your organization. Everybody has a different sort of monitoring maturity and roles in their organization, and you can look at these gaps in the maturity model and figure out where am I going to get the biggest impact. And because of RTV's modular structure, you can pick and choose those things. So now I'm going to leave it back to Gia and see if we have any questions from the audience.
Thank you very much, Dan and Rodney. We do have a question that just came in, and this question is for Dan. Dan, what is the role of the users in your organization that use your RTView solution, and how do they use it in their daily operations?
A number of different groups use RTView here at Litle. we have a support organization who is tasked with the sort of daily care and feeding of our platform. They certainly are, I would say, that the primary consumer. In our organization, all of the engineers sort of have or participate in supporting the platform, both from whether it's a research perspective or from helping out with a hard problem. So all the engineers are also periodic users of the tool. As I said, one of the things that's been really helpful for us is sort of the breaking down of the sort of silos of information. So the other place that the tool gets used is when for example, the database group needs to know more application-specific data, or the networking guys need to know more application-specific data or database data. The tool gets used in those cases too. So everyone sees that sort of common view and has a common place to look. So every time, the database people don't need to ask the application support people for, certain basic pieces of information about how the application is doing. So it's actually a pretty wide cross-section of people on the technical side of the organization. Also, I should mention, I actually meant to take a picture of this and put it in the presentation. We don't have a sort of formal mock here, but when you walk into the offices here at Litle, there's a couple sort of large, LCD screen TVs, and one of which is dedicated to a rotating selection of RTView displays. So anytime you come into Litle, everybody gets a glimpse of the tool, and it makes a great entrance to people to see how the system is doing, and it is kind of amazing sometimes just walking through, coming to the office, how you notice interesting things going on in the production environment.
Great, thank you, Dan. So we have a few more. One more question for you, and then two have come in for Rodney. So for Dan, have things improved about how you can react to troubleshooting application performance issues compared to what you used to do?
I think the speed at which we can get at information has greatly increased. Both because someone can avoid a lot of the sort of almost research efforts that need to happen. We had lots of data in our own application database, and you could query lots of tables to find out all kinds of interesting statistics. But now it's all in the tool, and that's definitely close the cycle, close the reaction time. It's just there. Multiple, and by having different types of data all in the same place, also really improves the reaction time. Say, okay, we're having a spike in our response times. Well, why? Is there a database problem? Let's go check the database view, and we can see, oh yes, look, there's some lock timeouts at this exact same time. Well, what's locking? Well, let's just drill down, and we can see, in a similar to the view that I showed with the top SQL, we have another drill down that brings you directly to more data from this health metrics database that I referenced that shows you, well, here's the queries that were having contention for the lock. So really, within a very short amount of time, you can, in this particular example, troubleshoot something that would have been a very time-intensive process that would have involved multiple groups and a great deal of domain expertise. And that's something that can be done now from, one of our support engineers just from their browser. Now, obviously, that's depending on some, very detailed information that we have in our database guys have put together in our own, proprietary database. But that's, RTView is really what's made that data useful for us.
Okay, great. Thank you you very much. I just want to remind everybody, if we're not able to get to all your questions during this event, we'll be sure to follow any unanswered questions via email after the event. And we will also be sending out the webcast, which has been recorded. So I think we have time for about 2 more questions. This one will be for Rodney. How should we determine which gaps in our monitoring solution would have the biggest impact?
Okay. Actually, I'll probably go back to a slide to help talk about this. So the key thing is to, try to get up to service and business aligned functionality. Even if you have just one component of information, it's your ad hoc application monitoring or whatever it is, if you can get to a service and business aligned level, it will change things you do in your organization, like Dan described, that you didn't even realize were going to change when it happens. So first, go to your business, go to your application support teams, determine what's a critical app or what's a critical group of apps that we are concerned about. Focus on that. Then think about, what data do I have? Do you have application information data? Do you need monitoring around the middleware supporting that application? Do I have sources of data? And if you don't, and there's important ones, you need to fill those gaps, and then think about, at least first step, single pane of glass. You want to get that information into the right hands and accessible. So that's the way I would first imagine that you would look at how do I want to fill the gaps.
Okay, thank you. Another question is, what is the typical process for people wanting to start an RTView for APM implementation?
Well, engage us. First, we'll help you do that. One of the things we do is actually question you about the things I just did. What are your critical apps? What are your critical sources of data? What are your current monitoring tools? And then typically we'll focus on one application or one application group sort of as an evaluation or proof of concept sort of things. If you have critical information that you want to get from various different monitoring solution packages we have around middleware or databases, oftentimes we'll just install that. Start up the data servers that start collecting the information right away and start populating it into our really default views of that information. So really in a single install that could be done in less than a half an hour, you could start putting together the first views of your information with metrics gathered by one of our solution packages. If in fact there is a really important piece of data that is not part of our solution packages, then we'll help you configure your own custom solution package, your own gathering of the data, using the builder, gathering the data and putting it into our caches so that you can stick that into the whole system. And then what happens is that then you start really seeing the value of it, and you can start figuring out, how much do I want to add? Do I want to add more performance data from different areas? Then you can create a solution package, add it to that. It's just stuck into the system and starts really then providing that additional piece of performance information to understand how that new performance data is impacting your service, your different service groups or applications. And so that's sort of how you can organically grow out and improve your system over time.
Okay, and we have one more question for Dan. I think we have some time for that. Dan, can you share more information about your external monitoring system?
Okay. Well, I mean, I'm not sure if I'm allowed to talk about vendors here, but there are a number of services out there that will, basically you can contract with that, and we've done this, that are basically hitting our services, our web services, and recording a result, and they have, a wide variety of geographic locations which can do this. We had actually implemented that ourselves by getting some hosting services, and And in both cases, we're, bringing it back to RTView a little bit, we're able to, integrate that data, so in two different ways, and basically show the same views. And I guess the sort of the interesting, point in sort of our philosophy, how we use the tool, is we don't try and necessarily pull everything into RTView, but use it as an entry point. So, in this external case, we are running lots and lots of tests. We test various services, and not all of them are super critical. Some of them are nice to know, and we don't try and replicate. The service that we work with, has their own interface, and they have lots and lots of data that's available to us, and we don't try and replicate that within RTView. They do what they do very well, but there are certain critical things that we do want, right in front of us all the time, and that's where our integration came into play. It may be the case that we may need to deep dive into an external tool to get at lots and lots of gory details, but nobody wants to be sitting with lots and lots of tools open all the time, and that's where the RTView integration came into play. So from our sort of philosophy, we want to have some of everything in RTView, but not try and rewrite the world using the RTView builder. So it's kind of a nice compromise.
Okay, well, thank you everybody for your questions. Thank you, Dan and Rodney, for a great presentation. As I mentioned before, the webcast has been recorded, and we will email a link to the recording within the next few days. Thank you for joining, and have a great day.